Welcome to the Simulx tutorial.
We will see how to use Simulx for the simulation of PK models.
We consider a one-compartment model, with first-order absorption, and linear elimination.
The mathematical representation of this model is a system of two ordinary differential equations.
We will use MlxTran for implementing this model.
The system of equations is implemented in a block equation.
Doses can be administered orally and intravenously in this system.
A block PK is added to the model.
The model can now be used for different tasks, including simulation.
Imagine, for instance, that we want to compute the concentration between time 0 and time 60 for a given set of PK parameters when a single bolus is administered at time 6.
We will use R for implementing this design.
Define first the output of the model.
Define, then, the list of parameters and their values.
The dose regimen needs also to be defined as a list.
We can now use R and run Simulx.
Let us source this code and plot the predicted concentration.
It is very easy to modify the dosage regimen and introduce, for instance, a rate of infusion.
We can also introduce multiple doses at different times with different amounts and different rates.
Let us now define an oral administration.
In our model, oral administration has type 2.
The same amount is given at different times.
Let us plot first the concentration, assuming oral administration only.
Let us see, now, what happens if we combine oral and IV administrations.
Until now, the model was used for computing the predicted concentration.
We can define a probability distribution of observed concentrations in a block definition. Here, the observations are normally distributed around the predicted concentration.
We will use Simulx with this new model.
A new output needs to be defined.
Simulx computes both predicted and observed concentrations.
We were considering a single individual with this model.
Interpatient variability of PK parameters can be introduced in a section individual.
A new R code uses this model.
Here, 5 individuals are simulated with their own individual PK parameters K and V.
In this code, 2 groups of 5 individuals each are defined.
Infusions are administered to the first group and oral doses are given to the second one.
Look at the documentation for more details about Simulx and more examples.
Enjoy Simulx.